Okay, question 59 here. Question is, prove that this point is a solution to the two equations there. So there, all we need to do is substitute in the x, the y, the z. So we could do it just here if we wanted to. So it's going to be 2 plus 2 times 5 plus 3 times minus 4. Well, so 2 times 5 is 10. So we've got 2 plus 10 minus 12, which equals 0. So that one checks out. Okay, and the other one, 2 times 2 minus 5 minus 2 times minus 4. Okay, so we're going to have 4 minus 5 minus minus is plus 8. And so that's going to give us 7. So it works out as well. So that's the first bit. And now, the second part, saying find any other equations in the form of that, which passes through those numbers. So, how might we do that? Well, let's see. Well, let's substitute these values in. Hang on, I might just give it a bit of a rule. Okay. Fine. Put this up now. Okay, so, well, what if I substituted these guys into here for x, y, and z? I would have a times 2, so it's going to be 2a, plus b times x, so it's going to be 5b, minus 4c. 4c is going to be equal to k. So I've just put them in, and now I need to find an a and a b and a c, which is going to make that work. So I might try and find some really easy values. And so why don't I just try, if I tried ones, what's going to happen? So I'm going to have 2 ones plus 5 ones minus 4 ones is, I'll get 2 plus 5 is 7 minus 4 is going to give me 3, right? 3. So that means my equation then could be, I could actually make my equation x, so the a I could make, so that what that is, that a is equal to 1, b equals 1, c equals 1. So I'd get ax be 1x plus 1y plus 1z is going to be equal to 3. Now I need to test that. Okay, so it says find an equation of the form which passes through that and demonstrate that it gives a unique solution with the existing two equations. Okay, so let's put the other equations on there. Let's call this one 1 anyway. And I'll put the other 2 on there. I've got x plus 2y plus 3z equals 0. We'll call that equation 2. And 2x minus y minus 2z is equal to 7. Okay, we'll move that up now. We'll call that equation 3. Okay, so x's look as though they're going to cancel that pretty well. So let's just do equation 2, take away equation 1. So we get x is eliminated. 2y minus y is y. 3z take away 1z is 2z. And 0 take away 3 is minus 3. And then with the 1 and the 3, I need to double this one. So I'm just going to go, I might do 2 times equation 1, take away equation 3. So 2 times 1 is 2x, take away 2x is 0. 2 times y is 2y, take away minus y is plus, so it's going to be 3y. And then I've got 2 times z, take away minus 2 is going to give me 4z. And I've got 2 times 3 is 6, take away 7 is minus 1. So now there's my two equations, and I need to solve those guys. So what am I going to do? Well, let's call that one 4 and this one 5. So I might eliminate the z's. So I could go equation 5, take away 2 lots of 4. So 3y take away 2y, it's going to be y. They will be eliminated. Minus 1 take away 2 lots of 3. 2 lots of negative 3 is negative 6. So minus 1 take away minus 6 is going to give me 5. So I got 5. All right, let's keep going. Now I'm going to sub y into equation 4. So move that up. So I get 5 plus 2 lots of z equals minus 3 is minus 8. So z is equal to minus 4. And I'll sub y and z in which one? I'll have to go one of these top ones. Let's do it into equation 1. So I'm going to get x plus 5 plus minus 4 is equal to, what did I say it was? 3. And so I've got x plus 1 is equal to 3, so x is equal to, is it minus 3? Oh. Just checking, 3. So I get x is equal to 2. And so then I've got my solution of x equals 2, y equals, what was y again? Y was equal to 5, and z is equal to minus 4. Cancel.